In the last session, we studied the standard C# code, like the variable, the loops, the if statement, the class, and so on. And now in this session, we're going to study the C# codes that are only specific to the Unity engine itself. And they consist of concepts and methods that are special to Unity, and they help us to control and create the games much easier. So if you're ready and you have installed the Unity engine according to what I've taught, or you have previously installed it, then let's begin. Okay, first open the Unity Hub and then go to New Project. We're going to start first from the 2D platform because that is easier. And so we select the first one, which is a core, and you can select every name. It doesn't matter. Just say tests because I only want to practice the codes right now. And this is different from the project that we want to begin later. It is open. It takes a while, especially for the first time. So be patient. So if you see the Unity engine for the first time, you might say, wow, there are lots of things here. But we get familiar with that. Here, we call the hierarchy. It means that everything we have, for example, we want to put the player, to put anything, the cube, the earth, we put them here. And this, the assets, is where that we put everything. That is a project window, which is, for example, we put the asset folder and everything that we want to store, we put it there. Imagine that it is like in your computer, for example, you have my folder and the folder you put there. And then you open, for example, you select some movies and you imagine that is this part that you select some movies to bring in your desktop and then you watch them here in the scene view. And the game window is the actual, game environment that you play. And and here is the inspector. For example, when you click on the main camera, you see that there are different properties here. Okay, so and here is it. So, as you saw, that we selected our project 2D, but you can change it to 3D every time that you want. So, or you made a game that is first in the 3D, you can hit 2D, and voila, that is 2D now. And these tools, you can move the scene here, or you can use the scrolling in the middle mouse, and then this is for something that you move left or right. For example, the camera, I move it left to right, or rotate it, or scale. These are the things that are most commonly. I Control Z to return everything that is original. So yeah, and the console is that when you want to debug your project. This is not something that the player would see when you export your game, but this is something for you. For example, you want to say if some codes are executed and there it shows what happened, or there are some error in their codes and it showed them. And these windows might not be open for you because I've selected them and I used them, but in the previous project I used them, but here, as you see, they're open, you can close them. And here's for animating your project. So that's it that you mostly want to know. Yes, there the file, for example, the most for this for saving the game or building the game. Currently, it is on the Windows. We can then later switch to Android to build a project and publish it. And there are the edit part, which mostly we use this part. I just want to show you which part are mostly used. We use this part a lot for package managing. So yeah, so don't worry about these menus too. It's easy. Let me close that. So, yeah. So there's a first spot. Just see them. And in this folder, we don't have anything to do with the packages. If you need to add anything to your project, just add to your assets and make folders, for example, to here. And this is the button to play the game. Right now, we don't have anything. Yes. And if I exit the game, you just play this again. And yes. So now let's open the Visual Studio to, because it takes some time as well. And when you open that, you need to again go to toilet, go doing your works because it takes some time to open that. So let's make it ready. So yeah, in the assets, create a folder. Make everything as neat as possible. Script. So the folder is just for your scripts. You can, for example, make the folder for audio. You can make folder for animation. Okay, then right click, create C# script, and name it. For example, we have the no testing. And remember, you cannot use this, but you can use this. You can use numbers, but you cannot use a number at first. And this is correct for making classes too, because the class name is made of this folder name. It took shorter time. Yeah. So as you see here, you say using Unity engines. So the library has selected and you have access to functions and concepts that are in the Unity engine itself. But if you erase this, then you see lots of errors. And also the mono behavior is related to the Unity engine. If you see, for example, if you again delete it, then you cannot use the Unity engine codes. So yes, and the start and updates are default for your game. But before I go to this part, let me explain something very quickly. In the hierarchy, click press the right button for your mouse, and we are working on 2D. So we have these things. For 3D, we use this thing for. So now for that we are in 2D. Most of the time we mostly use this. Sometimes we need to create empty object for parenting different groups. We also might use the camera if you want to have multiple camera, and also the UI. So just keep in mind that we use them later. I don't want to teach all of them right now. That is impossible. So okay, we have the 2D. For the sprite, if I click on that, for example, I want a square. As you see, we have a square here that has a sprite renderer components. This is called, because if I delete it, imagine that I make an empty game object. What's the difference between this game object and this and this? They are all the same. They are all game object, but the square has the sprite renderer. If I remove that, that's exactly the same as the game object. For the main camera, if I remove this and I remove this, they are all the same. So Each object that you see here is just a simple game object that has different components. So for the square, we can add, I can control Z and return that, but I can also say that. So that's the same thing. We had this before I deleted the camera, and there should be always one audio listener which is always related to camera. So this we have this empty game object, and you can add anything that you want. There are different components here. If you go, for example, not on, for example, we want to add a rigid body. For the 3D, we use rigid body, and for the 2D, we use rigid body 2D. Just there's some, as I told you, there's some text differences, but of course the function is different. But yeah, if in a rigid body for the 2D, for the 3D, that's the same spelling. So why we use that, for example, to give a gravity to our game. Because we could use any, for example, our sprite renderer also can have different components. I don't No, we don't want to talk about what they do. The important thing is that they are called components, and this is called a game object. I can add, for example, a box collider. It doesn't show anything because I don't have any sprite here, so let's add it. Yes, to change the picture, for example, if you want a picture of anything like this, you change this here. So yes, and a game object can have different components, okay? So these are called components. So let me remove them. Okay. Let's look at our different game objects here. What is common between them? If you look at them, the transform component, even in the game object that was empty, it has transformed because, oh, let me remove that. Let's create a new one, empty, okay? Because every game object should have a place in the world. Whether it is 2D, for 2D it has X and Y, and for the 3D it has X, Y, and Z. So each of them should have a place. So that's why by default they have the transform. Okay? So but in the code we want to change the position, for example, the position of this square. We should have at least one camera so that we see through that. And now we have the square. Let me change the picture to something better. And making it a little bit bigger. We want, for example, that it moves from here to here. So that's where we have to become familiar with these two concepts, which are very important. And for all career of your Unity work, you're dealing with them. The start function is a function that is only triggered once at the beginning of the game, and it is for setting things. For example, I want that when the game begins, my player have, for example, 100 health. Okay? And the update, as the name implies, it updates every frame. And for example, if you want to set the position of an object, for example, for the first time, you want to say, that's my player. I want that it be beside a tree. Okay? You say that is there. But in the update, you say, I want that the player move. So every frame has to move here, 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 here. so that it continuously works. So for things that we want that continuously happen or continuous check, for example, you want to check if the player is alive or not. You cannot check it in at the first part of the game because of course the player is alive at first, but every time in the game it might die, so you have to check at every frame when it dies. Of course, later that we go, we have the, for example, the triggers and actions triggers that you can check by that. But for now, one way is that we check it in the update. So we also have other things like fixed updates, or you want to, for example, you have late update. It's good to have. Now let's see how I make it complete. I had said late, and it bring me the list of the word. Now I press tabs, the tab on the keyboard twice, and then voila, I have this. So what's the difference between that? The update works on every frame, but the fixed update, for example, if you have a very good computer and it is fast and every framework time is different. So if you have a faster computer and it can process the framework frame rate much better, then the player moves faster. So now imagine that you have a multiplayer game. The one that has a better computer, of course, he wins because he can run faster. But if you use the fixed update, then everyone is equal because it's not dependent on the frame rate, and it has a fixed amount of time to update each frame. Okay, and we have a late update, which is good for camera movement. For example, in update you move, and slightly after that you want that the camera move. So we use late updates. These are the examples. Update is good for the time that you want to receive the input or calculate the non-physics related things. Fixed update is better for example, you have the rigid body or some physics related calculation. And late update is, as I told you, for good for camera movement, smooth camera movement. So yes, but most of the time, even the update can do a lot good, so you don't have to be worried about which one to choose. And yes, we can use all of them in your project, but now I want to focus on that. And to better demonstrate what each of them do, I say debug that's log. It is something that doesn't do any special thing in your game but help you to debug better in the console part. So for example, I say debug and I say a start and in update I say update. And then I have to save the game, Control S, or come here and save the game, save the codes. Then as you see, it's compiled. Then we press to play the first piece of code. But why it is not shown anything here? Because if you want that piece of code to work, first it has to be connected to a game object, and also your game object must be here. For example, I give this to this. Okay, now it has even this script is a component to that. But if you just have the square in the project window and don't bring it here, then nothing happened. It has to be in the hierarchy. So you should have a game object and the code attached to that. Yes, there are some cases like a script object that is different, but for the ordinary codes, you have to do something like that. So now let's play the game. It's not a game, but testing. You see, the start has only been initiated once. But for the update, if I don't collapse it, the update is doing its work. And if I collapse it, I see that, the similar things are here. Yes, as you see, it increases. So now you understand it better. Okay, so what's in real game purpose of that? This is not a good thing. Okay, as you understand that, let's move to better examples. I want that this square, when the game starts, it moves to 0, 0, 0 position. Now that is not, it is in the -5 to, I want at first it goes there, and then at every frame it moves to right. Something like this. Okay, is that a better example? Okay, let's go. And be aware that we want to manipulate and do calculation on the transform components of this game object. Okay, we want to change these values. Of course, you can also do with rotation, with the scale, but now we want to work on the position. So let's go. So that is the code that I've given to that. Okay. Here, we say the name of the component. What is this, the name of the component? This is transform. And exactly, we say that word. Dot. So which one you want to change? Position, rotation, or scale? I want the position, please. So we say position. Now, equal to where? So for the place, we use the vector. So please memorize this. I cannot explain this more. You can, for the 2D, you can both use vector 2. It means that in the space where it should be, and I say I want to be 0, 0. It means x and y for, and 0 for y. It means that your position should be in the x 0 and y 0. And for the 3D environments, we also have z. So I have to say 0 for the z. And for the 2D game, it's okay to use vector 3 because, but we have to give the z the 0 because we don't use that. Most of the time it's just 0 for the z. Okay? And now I want that it moves to the right. So for the continuous movement, which function or method we should use? Yes, the update. And again, we say transform that position. For example, you have first the position and then you want to add something that is transform that. Sometimes you might forget, but just yes, it means that you have to go forward. Just as a full, and then it will type for you forward. And in time, the delta time. This is one way, and I'll explain you later. Don't worry. There is another code that is. I want you to be familiar with all of them so that in different project that you see one of them, you know that, okay, this can also be used. And it might have a different purpose, which I tell you what are they. So that is transform dot translate. No, there's no equal. Open the parentheses, and that is vector 3 dot right. For example, you can multiply that with the speed, which is not important right now. Yes, you can just by 2. For example, the speed is 2. and time the delta time. So, what is the difference between them? Let's imagine a car. A car can go forward, can go backward, can go left and right. If you want to give the car, for example, you say that, okay, I don't care. Just go 2 units to the right. Then you use transform.translate. Okay? The initial position is not important. Just go and park somewhere else. Okay? But in the transformed position, plus equal, first, for example, your car is in front of the house, the initial place. And the man from the neighbor comes and say, oh, move your car from here, from my door to somewhere else, to the forward. And you use this code. But imagine the car is rotating. The forward is always related to the car. For example, it might be on your right, but for the car, the forward is the tip of the car. Yes? So it depends on your usage. But for now, don't worry. Just be familiar that both of them can be used. And also, there's another way. But let's try this for now and see the differences. So the first one is this. Let's hit play. The code is compiling. As you save the game here, it compiles the game. So that's why you see that green bar. So let's see what would happen. We don't have a background, so we cannot see much, what happens here. So let me quickly add the background. Okay, so I brought my background here. I just drag and dropped from desktop to this. And then I put it here and I scale it until that is the size of the camera. And as you see that the sprite went back, oh, they can change the Z position. If you go to minus, then the Z come. I know that is a very fancy background for this cube, but it's fine. But before that, this works for the 3D environments. For the 2D, we should say something like forward right. The transform, that's right, okay. And let's save it. Because we're going to focus just in the 2D game right now. Oh, it moves moves here. But the Z, okay. It goes forever. Because I told in the code that's okay, you have to be 0 unless you can, for example, say 1 is 1 or just get rid of that. There's also something else that you can do. So yes, these are two approaches to the vector 2 and only with two starters x and y, or just increase. If you go to minus, it automatically goes behind. For example, if it is 0, if I make the background to increase the z, then it will go behind the other things that has lowered z. So let's try again. You see, oh, that's so cute. Yes, and it continues forever. And bye bye. Oh, it went completely. So that's it. As you saw, you know, the cube is here, but it starts from the middle. You see, it started from here. Because here, at the start, in the start, we said, okay, let's do something like this. But if you pause the game and remove it, let's see what happens. It is start from the position that we gave it manually by hand. Okay, because at first we didn't say where exactly to start, so just so wherever that we have placed it. So now you understand this start and update. So now let's change this to this and try it. You can have that. Just see the differences and see what would happen. It moves again, you see. For most of the time, we don't need to be really paying attention to the differences, especially in the 2D platform. So, yes, you know how to move. And also, so we have talked about the position. You can also work with the rotation or the scale, but there are many things that we can talk. Yes, in the project, we're going to use that. But for now, let's move to something else. If you want a realistic movement that would be affected by the gravity, and for example, when it hit the wall, which is a collider, it has, realistic reactions, then we have to use rigid body. So let's go here and to our square, that is our play. Oh, that was a very ugly name. Imagine that this is our player. No, this is more alive, so we get a real name. So add components, and we go and add rigid body 2D. So here it said body type. The dynamic was something that I was describing before, that it reacts to the pushes, the pull, and other, reactions in the game, to the gravity, to physics. Here we have the kinematics. It means that, okay, it denies all of the forces, for example, like gravity, but yes, it can move. It's good, for example, for doors, for the platformers, for the 2D platformers, and you have a static. It doesn't move at all. For example, like walls, floor, something like that. But here we want dynamic one. And for realistic game, I will say you how to use these parameters. But for now, it's not important. Now, if I hit play, I do not do anything. I just hit the play button. Wow, it fell down. Why? Because it has gravity. Okay, the gravity scale is 1. What if I make it 0? Ah, the gravity now doesn't apply to that. It means that it is like air moving. So, and even you can give, the gravity scale, for example, like I give it 7. Let's see what happens. Whoa, it was so much faster. So some people, when they want to make realistic jump and falling down, they think that they have to change the mass. No, change the gravity scale. For example, for sharper falling down, bam, you have to increase the gravity scale. I put it at 1. So what to do? It just fall down. It disappears. So the thing is that I can make another 2D object. For example, I can choose different things, but I can still choose a square. And I can, for this scale, I can use this one, or I can manually, do this. I can change the color here to red. And let's see what happens. I added a sprite. Wow, it again fell through that. Why? Because how it's going to detect that it should stop? It doesn't know. You are the programmer. You have to tell it where to stop and collide. So that's why for this I'm going to give it a collider, a barrier that it said, well, you shouldn't pass through me. I'm the earth. So, yes. And there are two things which I will tell you later right now. Just let's see what would happen. Oops, it again fell down because it thinks that it's a ghost because it doesn't have any collider. I'm a human, and for example, I have the physical body, and the wall is also physical, so we can collide. It can stop me from going through. But if I'm a ghost, then it means that I don't have any physical body, but the wall has the physical body. But I don't care. I don't have it, so I can pass through that. So it is important that you also give your player a box collider. You can give other colliders, for example, circular collider, it has to be 2D, okay? And the polygon, and you can also change the size of that by pressing this and then changing that. For example, you have an arrow, if the enemy shoots you and you want to cheat, okay, say, okay, just only decrease it so it would hurt less, by the less area surface. So, of course, now let's see what would happen. Bang! It worked! No, tiny little players playing. Actually, this is a play, but we don't play that. It just goes for himself. And later, we have a way to control that. Don't worry. But let it be himself and have his own space. Okay, another important thing that I have to explain is time.delta time. What does it mean? If I remove this line of code, okay, it means that I want to move my object, anything moving, rotating, scaling. I want to, for example, moving my object every frame, for example, for 3 or 4 meters, So it is frame related, as I've explained it in the update and fixed update. And for the computer, for example, that runs on 60 per frame, 60 frame per second, then it would move faster. But a computer that runs the poor actually runs on the 30, then it would move slower because the movement is frame related. But when I use time.delta time, it means that it calculates things and corrects things. For example, you say that I want to move this 10 units per second no matter the frame rate. The time.delta time just calculates things. For example, if you have lower computer or better computer, it just calculates things inside himself. So both computer with, for example, move the player at the same speed. So that's why to have this here. And we see in some other calculations. So yes. So now, as I told you, we're going to use the rigid body and how to call that. So now, the square, yes, if you want this only be affected by the gravity, that is enough that, let me change the names. BG square is the floor. It's always good practice that you have naming correctly. Because, for example, if you see, I was even confused between three objects. So always be aware that you have to give a convenient name. Also for your codes, for example, later, for example, we have a string name of the player. Don't say string A, string B, because after, for example, 6 months, you say, okay, what the hell was A and B? But if you say, for example, a string uh, um, or int player health, you always know that it was okay for the player health. So always give good name to your things, whether here or whether in your codes. Okay, so yeah, that was enough. Just if you wanted to apply the gravity, just adding a rigid body, but you want that it moves. For example, we're gonna let it here. You want that it moves and be applied by some certain amount of forces. Then how to do that? Ah, that's a little bit tricky. And this way that I'm going to introduce you is correct for 99% of the things that you're doing. As you see, the rigid body is a component that I manually added here. So I cannot direct. So yes, for transform, I directly set transform that position. But can I say rigid body, for example, that's something, um, because the transform that position is always in the code, for example, um, attached to every game object. You don't need to do anything else. But for the things that you manually add, then you have to do an extra step. First, for example, for the string name, it's equal to double quotation here. You set variable, you did something. Here we should use that, okay? Instead of a string name or integer number, I use the same thing. I want rigid body. We usually say RB. So I want an RB or rigid body of type rigid body. So that I declared it. So does it alone is enough? So which rigid body? Rigid body of who? Because you can access to, for example, from here, we can access to other things. Rigid body, you can access, for example, if you have enemy, you can have access to his rigid body too. So yes, it defined it here, but which rigid body? If the rigid body is on the player itself, for example, let me get rid of that or just comment it. Maybe you just want to look at that again. RB is equal to, so these are components. So I say get components. You don't say, for example, let me say a clear example, a string name. Okay. And here we come and say, okay, the name is, for example, Sarah. The same thing happens to that, but the difference is that you have to say get components, and then use this. Which one of the components you want? Box glider, you want sprite, you want rigid body, which one? I say I want rigid body 2D. So why this is, oh, I'm sorry, I didn't say 2D here because we are working in the 2D environment. So you have to, yes, it was 3D, then you had to say rigid body. But we are in the 2D environment, so you have to be careful. This should match exactly as this. So yes, I want the component that is the rigid body 2D, and it had to be exact name. Okay, just as they declared the thing here. You also do that here. Now you have the access to your rigid body. So what do you want to do with it? Then I say RB that I want to apply a force. I say add force vector 2. If it is 3D, use 3. But now we are in the 2D. That's right. Okay, so it moves right. And I want to apply force by For example, by 10, oh, it would be so much. So at first I apply the force for 2. Okay? Not only it moves in that direction, but in the force of 2, So yes, if you know the structure, just be familiar with the appearance of that. That is okay. Coding is not about memorizing. Just know what it does, what is this, what is right, and that is enough. So yes, we declared here. We say that okay, the rigid body, this works on the rigid body that is already on the same game object. Just be reminded of that. Be careful of that. Okay, now we have your code. Now let's see how this happens. Ooh. So what if we can do things like, for example, I can say public and for example, the force is equal to, I give an initial value, so instead of 2, I say force. Here you see that force came for us. Wow, now I can directly change from the inspector. I can change it to 4, to whatever number that I want. Yes, the code is 2, but the priority is by something that I change here. Even if I change the number here, it doesn't change the number here. So you have to always change this. But with that give initial thing for example, if you want to give the codes to other things that doesn't have any initial number here, so it uses that number. Or you can say, for example, reset, and it resets to the original number that is here. Now I want to change it to 4. So woohoo! Yes, and even I can change during the game, but it is not a good example to show that. If you want to declare a variable, but you don't want that you show it here, you can. So if you make it public, not only the other codes and other classes can have access to that, but also it is shown in the inspector, which is here. So make it private. And voila, this is gone. But if you want, in this manner, no other codes can have, no other classes can have direct access to that. But you want to, okay, I don't want that other classes access to this, but I want that it be access, at least shows in the inspector. Then we use serialized field. Just add this before the private. Actually, that's a very good practice that you add this type of thing instead of using, just make it public for your every variables. So let's see what happens. It's again returned. So can I use for rigid body as well? Yes, you can make it serialized field or public rigid body 2D or serialized field private rigid body 2D. And the good thing is that you don't need this anymore because you're going to assign that in the inspector. So you don't want to get component thing, you can make it like that. But remember that you go there, you have a rigid body, and do something like this. Just grab the component and put it here. If you grab other components, it just doesn't accept. So if it accepts, then it means that you're right. And I also want to say how to get components from other objects. So let's quickly say that. For example, I have 2D, and this sprite, no, this is a triangle, and it is red. It means that it is the enemy. Oh, oh, this match the same color. So can I put the enemy blue? Blue is a good color, but yes, the red. So I make it red, and let me bring down a player. Wherever you put the player, the game would start from that point, unless that you set the place in the start function. Okay, I have this, and this is the enemy, and it has a rigid body 2D as well. Okay, and I give this a collider too. For example, I can give polygon collider, and then this is fine. And now let us play. Just play this. Ooh, that was fantastic. Okay, so if you don't want it doesn't rotate, did you see that it rotated? Let me play again. Ooh, you see that the cube just tilted and rotated. If you don't want that to happen, for example, you have a human, you don't want that the head goes down. Just go to rigid body constraints and just freeze rotation on the C. And let's see what happens right now. It moves, but it doesn't rotate. It doesn't mean that it wouldn't go to air. It goes, but always the head, if it is head, if it goes up, the head is always here. But if I don't freeze the rotation on Z, then it would go, for example, the head would go down, some weird things. So we usually freeze that. Okay. Now imagine that I want to get the rigid body of this game object. I'm the player and I want to get the rigid body of this. So um, the first thing is that, yes, you have the player and you grab this to this. Because it had a rigid body, then here, if you grab it, then it automatically selects the rigid body of the triangle. So this is one of the ways. But sometimes you have lots of things that you don't want to manually attach things to others. So there is another way that is, okay, I want to manually do that. Then how to do that? Say RB. Yes, we have the same thing, but it is still gets the rigid body of the player. It gets, oh, I didn't save the code, so yes. If I say get components, it just gives the rigid body of the player. But I want to get the rigid body of the triangle. So how to do that? One way is that to give it a tag. For adding a tag, I do this again. Go to this tag, add tag, and for example, say enemy, and save it. And go to triangle and select the enemy. Okay. Note that it's tagged as enemy. Then here, before that, you say game object dot find game object with tag, what was the tag? Enemy. Then get components, which previously had. So now you have a rigid body of that triangle, which was tagged as enemy. Why we don't use time.delta time for rigid body? Because actually it has some inner calculation that make it kind of independent from the frame rate, so you don't need the time.delta time. But it is better that you put it in the fixed update method, because somehow the force might change by some fluctuations in the frame rate in the update. Now that we talked about the rigid body, let's add something else. There's also another way to move the character according to the rigid body. It's a rigid body that's velocity is equal to new vector 2 x and y. For the x, for example, I say 4 and then 0 for the y. So this, what's the difference between this and this? The first one actually makes the player to move in the accelerating speed and force. For example, it is start from lower speed to more and more it increases its speed. But the second time, it is a constant. It has a constant speed and it moves in a constant way. So let's try this too. Let the code compile. Yeah. So they have different usages. Most of the time, add force is something that's, for example, for shooting, for jumping, that is better. But this for ordinary movement, that is better. And instead of 0, for example, I want to say that always keep your height at the same position. For example, I want that the height be the same, so it wouldn't come up or down. I can also say rb dot velocity dot y. So whatever your height is already, just try to keep that. So you might change to see something like this. And this is a number. That's it for today. So practice them well. One of the best things is that you try to write down on the paper. At first, try to think. And don't just try to look at your notes or look at this. First, try to see if you can remember anything, okay, and then write. If you couldn't remember anything, okay, you can practice and look at the code. But the second time, try really harder that you try to write it on your own, because the pressure that you put in your brain can change the circulation in your brain and boost your learning. But if you're kind of a person that always copy pasting is good when you understand the code and for example, you have written it a lot of time and that is a wasting of time to write it again. So yes, it's copy and paste. But during the learning process, try to avoid the copy and pasting and try to write down yourself, okay?